Hello and welcome back to Mr. BECE Maths and Econs channel. This channel was created to help you achieve excellence in your maths and economics. In today's video, we will be going through number base, also known as binary operation or binary arithmetic, right? And this is about going through questions from the Lagos State BECE Maths to prepare you for excellence in your upcoming BECE exams. Are you happy to be here today? If you're happy to be here today, can I hear you say, I am happy? Aha. Okay, let's get started into solving the questions. So the very first question we have today says that simplify 110,110, take away 101101 base 2. Okay, so this is a BECE pass question. So what do you have to do? Just write out the numbers, align them correctly. So we have the number that stays on top is going to be 1 1. This number is going to stay on top, so 1 1 0 1 1 0 base 2, take away. So you just have to be careful when you're writing the next digits, the next number. I think it's very important. My strategy is to start from the unit digit, basically, right, from the last digit on the right, so that I can write it backwards. So I do 1 0, I do 1, then 1, and then 0, and then 1. The essence of this is just to make sure that all the digits are well aligned under each other. So then what do? We add and subtract. So there's something you need to just remember very quickly, that in binary operation in base 2, 1 plus 1 is meant to be 2, but because you're in base 2, you cannot have any number that is equal to the base or more than the base. So the number has to be less than the base. So we are in base 2. So all the answers we get should be in zeros and ones because it's binary. So 1 plus 1 is meant to be 2 in base 10, but in base 2, 1 plus 1 is 10. And 1 plus 1 plus 1 is 11, as you already know. And then 1 plus 1 plus 1 plus 1 is 100, right? So, but in many of the cases, and then 1 plus 0 is basically 1, right? So in many of the cases, you don't really get to use the 100. So just know your 1 plus 1 is 10 and 1 plus 1 plus 1 is 11. But this is a subtraction anyways. So to do this, so this is 0, it can't work. So we borrow 1 from this digit. So this is going to become nothing. We're gonna have 0 left there, and then the one we borrow from here comes to this place to become what? It becomes the base, because the base is base 2, so you're going to write 2 here. Okay, so 2 minus 1, that is 1. We have 0 left here. 0 take away 0, that is just 0. 1 minus 1, that is just 0. And this is 0 again. You have to come here to borrow this 1. Then we have 0 here. Because we're in base 2, when it gets to this place, it becomes 2. Okay, it becomes 2. So 2 minus 1, 2 plus 0 is basically 0. So 2 minus 1, 1, right? 0 minus 0, 0. 1 minus 0, 0. So we can just ignore this last two zeros. So our answer is essentially 1 0 0 1 base 2. And that is option A. Okay. That said, let's go on to the next question, which is question number 2, the multiple choice question number 2. If you haven't seen the previous videos, make sure you go and check them out, okay? Very important topics that we've covered for your BECE exam. Now, the next one here says convert 1011 base 2 to base 10. So whenever you're converting any base to base 10, I believe you already know what to do, right? So the first thing is you write out the number 10111 base 2. Then on top of each number, you add the power starting from 0 and starting from the right to the left. 0, 1, 2, 3, and 4. So what do you do then? Each of the digits, which is the first digit here, is 1. So we're going to say 1 times the base and then raise to the power that you have here. Plus the next digit, which is 0, times the base, which is 2, and then raise to the power that we have there, which is 3. Plus 1 times the base, which is this one, times the base 2, raised to the power of 2, which is 2. Plus the next digit, 1 times the base, 1 times 2, and the power here is 1, so this is raised to the power 1. Plus 1 times the base, and the power here is 0, so this is raised to the power 0. Easy, right? Okay. Now, 2 to the power of 4 is 2, like 2 to the power of 4 just means 2 times 2 times 2 times 2 times 2 times 2. 2 times 2, 4. 4 times 2, 8. 8 times 2 is 16. So this is 16. And then 16 times 1 is just 16. Plus 0 times anything gives you 0. Plus 2 to the power of 2 is just 2 times 2, which is 4. 4 times 1 remains 4. Plus 2 to the power of 1 is just 2. Times 1 remains 2. Plus 2 to the power of 0 is 1. 1 times 1 remains 1. And then we add everything together. 16 plus 0 is 16. Then 16 plus 4 is 20. 20 plus 2 is 22. And 22 plus 1 is 23. Base 10. So answer is option C. Okay, this is really good. And the last multiple choice question for today is express 341 base 5 as a number in base 10. So essentially the same thing, right? The same thing we just did over there. We basically, first write out the number. we got 3, 4, 1, and then 5. So you write out the number. You have 0, we have 0, 1, and then 2, right? So since we have that, we basically now then say that, okay, excuse me. So then we say each of the digits, for example, the first digit is 3 times the base, which is 5 to the power of 2, the 2 we have here. Then the next one is 4 times the base to the power of 1 plus 1 times the last digit, which is 1 times the base to the power of 0. And that simply gives us 5 squared. 5 times 2. 5 squared just means 5 times 5, not 5 times 2. 5 squared means, so this is a popular misconception. It means 5 multiplied by itself. 5 times 5. And 5 times 5 is 25. So now 25 times 3, that must give you 75. Okay, 25 times 3. 3 times 5, 15, 1. 3 times 2, 6 plus 1, 7. But you should know this mentally. You know, it's just 25 plus 25 plus 25. So that's 75. Plus 5 to the power of 1 is just 5. 5 times 4 is 20. Plus 5 to the power of 0 is 1. And then 1 times 1 is 1. So anything to the power of 0, just like I explained in the previous question, anything to the power of 0 is always 1 in maths. So final answer, 75 plus 20, that's going to be 95. And 95 plus 1, and that will be 96. Let me see if there's any mistake. Doesn't look like I have that answer. 0, 1, and 2. Express this as a number in base 10. So 5 squared, which is 25 times 3, which is 75. 5 times 20, which is 4 times 5 to the power of 1, which is 20. And this is 1. So 75 plus 20, that's 95. 95 plus 1, that is 96 base 10. I just believe I've not done anything wrong. So because the options don't even look like what we got, but I think there might have been a mistake in the options. So therefore, we must be correct. So express 3, 4, 1 base 5 as a number in base 10. Just the way we did in question 2, the multiple choice question 3 is meant to be the same thing. So there could have been a mistake in the process of getting the question. So the answer to this is 96 base 10. Okay. All right. Without further ado, let's go straight on to the theory questions. Whoa, this is okay. Binary question. The question here says convert 110.102 to a number in base 10, and this is our first theory question. So what do we do with this question? It's a binary. Some of you might be familiar with how to do it, some of you might not. So let's do it together. So all you have to do is write out the numbers 110.101. So we want to convert these to a number in base 10. So we know we're going to label, this whole part as 0, 1, 2, and then the fractional part, if you want to label these fractional parts, you want to add the power to the fractional part, you basically start from a -1, -1, -2, and -3. Okay, because they are now in the what? They are now in the position of tens, hundreds, thousand, and so on and so forth. Are we together? Okay, now the usual thing we know how to do is let's take care of the left hand side first, which is the whole number path. We're going to do 1 times the base, which is base 2 to the power of 2, plus 1 times base 2 to the power of 1, plus 0 times base 2 to the power of 0, and this is going to give you 2 to the power of 2, which is 4, plus 2 to the power of 1 times that, which is 2, plus 0, and that's going to give you 6. On the other side, we have this, right? Now, it's the same thing, the same idea. The 1 here times what? 2 to the power of -1, which is the power, plus the next digit, which is 0, times that, and the last digit, which is 1 times 2 to the power of -3. So we're going to have 2 to the power of -1. Oh, let's just, okay. Yeah, so 1 times this just remains the same, plus this is going to become 0, and this is going to become, this also remains the same. 1 times 2 to the power of -3 remains 2 to the power of -3. So therefore, we're going to have 1/2, because anything, so in indices, this is a little bit of indices. So in indices, if I have a to the power of -1, it just becomes 1 over a. 2 to the power of -1 becomes 1 over 2. Okay? So what about 2 to the power of -2? It becomes 1 over 2, but because this is not 2, it becomes 2 to the power of 2. So this one was a to the power of -1, it becomes 1 over a to the power of 1. 2 to the power of -1, a over 2 to the power of -1, 1 over 2 to the power of 1, and so on and so forth. So essentially, to get rid of the minus, you just change it to a fraction. So 1 over 2 plus that is going to give us 1 out of 2 to the power of 3. And we know this is 1 over 2 plus 1 to the power of 2 to the power of 3. 1 over 2 to the power of 3 is basically 1 over 2 to the power of 3 means 2 times 2 times 2. It's 8. So I've got 1 over 2 plus 1 over 8. I like to make them the same denominator because I'm trying to add up these two fractions. So this denominator is 8, but the second denominator here is just 2. So the question I'll ask myself is, what do I multiply by that to make the denominator 8? And the answer is 4. So the same thing there. We have 4 out of 8 plus 1 out of 8, and that gives us 5 out of 8. So this is the whole part, and this is the fractional part. So what do you now do? You basically just bring both of them together. So our final answer is going to be 6 plus 5, 8, which is 6 whole number 0.58 and base 10. And that's the answer. So yeah, that's the first theory question done. Now let's go on to the second theory question. Okay, so for the second theory question, we're told that we have a decimal number. Decimal number just means a number in base 10. So convert the decimal number 6.375 base 10 completely to a binary number in base 2. Okay, completely to what? A binary number in base 2. So what do we do and how do we do this? Very easy, as you already know. So 6.375 base 10. So we have a whole part and we have a fractional part. So we do the whole part first before the fractional part. So for the whole part, to convert a number from base 10 to another base, all you have to do is just continuously divide that number by its base till you get to 0. So the first one here is going to be, we have the number in base 10 is 6, and we start to divide by 2. So the first thing to do is 2 in 6, that's going to give us 3 with a remainder of 0. 2 in 3 is 1 with a remainder of 1. 2 in 1 is 0 with a remainder of 1. And then your answer is, you're going to go all the way up. So therefore, that is 110 base 2. But don't forget, there is still the decimal point, the fractional part, which is this. Now, this part, some of you might not be sure. Now, if you look at the previous question, what we did was converting from what? From base 2 to base 10. So from other bases to base 10. But in this case now, we are now going from base 10 to base 2. So for the decimal part, what do? You simply what? Write out the number, which is 0.375. So what you basically do is that you just repeatedly multiply this number. You repeatedly multiply this number by 2, which is the base, to convert it to base 10. So 0.375 times 2. 2 times 5, 10, 0, carry 1. 2 times 7, 14 plus 1, 15. Carry 1. 2 times 3, 6 plus 1, that's 7. And then there is a decimal point of 0. So the answer we basically got is 0.75. Now, if you want to write your answer, here, this part is going to be for the whole number. And this part is going to be for the decimal. Okay? For the whole number part and the what? The decimal part. So we have 0.75. So our 0 is going to be here. And our 0.75 is going to be there. Okay? So 0.75 now, which is the answer we got, will now be multiplied by 2 again. So you repeatedly multiply, you do this repeatedly over time, okay? Till you get to maybe 0. Or you have done it over time and over time, you have to stop maybe after like 4 decimal places. So 0.75 times 2, let's write it this way. This is just the same thing as 0.75. So add the 0 to it. 7 times 2 times 5, 10, 0, carry 1. 2 times 7, 14 plus 1, 15. And then put 1 there. And then 2 times 0, 0 plus 1, that's 1. And where am I going to have my decimal point? I have 7, 5 after the decimal point. So I should have 2 digits. 1, 2. So my decimal point is going to be there. So therefore 1.5. So this time my 1 is going to be here. And then my 0.5 is going to be there. So 1.50 and 1.5 are just the same. Do the same thing again. We do the same thing. So this 0.5 now, which is 0.5. You multiply that by 2. By now, you should know 0.5 means half. And you multiply half by 2 should give you a whole number 1. So answer is going to be 1.0. So 1.0. So we've gotten to 0. You can what? You can stop. Okay? We can stop over there. So final thing to do is to go from the top to bottom. Go from what? Top to bottom. So to pick up the answer that you need for the whole part, you just go from the top to the bottom. So the whole part is the answer that we need. Okay? Don't get it twisted with the other one where we have to go from bottom up. You have to go this one from top to bottom. So if you look at that, what we have is what? 0, 1, 1. 0, 1, 1 base 2. And because it's the decimal part of the entire question, we're going to have a decimal. So our final answer is just bringing this. Okay, I read the decimal here already, so you can leave it. So you bring this and these together in our final answer. So our final answer will be 110.011 base 2. That is our final answer. All right, I hope this is clear, and I hope you found this useful and helpful. So you should know how to work with binary numbers and decimal numbers and with decimal points, because that's something that you expected to know. So that's the answer to this. The whole part, you do it normally, and then the decimal part, you basically keep multiplying by the base. In this case, it's base 2 till you get to a 0, and then you stop, and then merge both of them together. Remember to put the decimal points in between them, and that is your answer. Okay, now it's your turn as usual. So here are your questions. In fact, I had to give you some bonus questions in this one to make it 7 questions altogether. So do it. Do your best. The first 5 students who submit their answers on the YouTube comment section of this video, I will personally mark your answers. And the rest, make sure you submit so you can basically check the ones I've marked to see how much marks you got and how much marks you missed. And I wish you all the very best. See you in the next video. Bye for now.